Hello friends, my name Dr. Sunil Kumar Jatav. Today I am going to discuss about the iron carbon equilibrium diagram. So you are welcome in the channel Meta Engineering. So what is the iron carbon diagram? So our iron carbon diagram is a the phase diagram is a the phase diagram the phase diagram. It provide the graphical representations of the phases with respect of the time, with respect of temperature and compositions. So first is the iron carbon diagram. Sorry, it is the equilibrium diagram. Okay, equilibrium diagram. So iron carbon diagram is the graphical representation. Is the graphical representation of phases. Which phases? Equilibrium phases. So this is the graphical representation. So you know the iron carbon diagram. So this iron carbon system, so generally the alloy of iron containing the carbon. So carbon is the very important alloying elements. Carbon is the important alloying elements. Important alloying element. Which? Carbon. This affect the affect the allotrophy, allotrophy and structure and properties of iron. So carbon is the important along element which affect the allotrophy, structure and property. With increasing the percentage of the carbon, the properties also change and allotropy also change. So it is depends. And in respect of temperature, these allotropy is also changed of the iron, and there have every phases have the different solubility, different solubility of the carbon. So what is the importance of studying importance of study of iron carbon diagram? Why we study the iron carbon diagram? So first is it gave the commercial basis. It gave the commercial basis. The commercial basis. It gave the commercial basis for the steel, steels and steels and cast irons. Second is these many basic features of the system affect the behavior. The basic features affect the affects the behavior of most complex alloy, affect the behavior of behavior of most complex alloy steels. Alloy steel. So steels may have the many accidental element or many intentionally added elements, so that modify the this diagram. So these modifications are the interpreted by using this iron carbon diagram. So this diagram act as the good guide for the uh, interpretations of the interpretations of for the interpretation. So it is act as a good guide for the interpretations of alloying elements. So this is the some importance of this diagram. So we also study the some other features of this diagrams. Uh, so in the next slides we will start here. So conventionally the complete diagram should extend from the 100% Fe to the 100% carbon. So the complete FEC diagram complete FEC diagram should should extend from 100% Fe to 100% carbon. From 100% Fe to 100% carbon, but commercially it is steady, but but commercially it is studies up to 6.67% carbon. Why? Because uh, why? Because the the iron alloys of the practical industrial importance only content less than 5% carbon. Like any alloy steel which contains only less than 5% carbon. So due to 5 we study up to the 6.7% carbon. 6.7% carbon. So this diagram we study from the 100% iron to the 6.67% carbon. It is the part of it is the part it is the part of FEC diagram, because FEC diagram content up to the 100% carbon, but B study for the commercially use up to the carbon percentage 6.67%. This is 6.6% carbon. This 6.6% carbon produce produces this 6.6% carbon produces 100% Fe 100% cementite. 100% cementite. This is the iron carbon diagram that is called the cementite. So carbon should present as the carbon should be present as the graphite, but it has the very lower free energy than the cementite. So free energy of free energy of graphite is lower than cementite. So yet we say the formation of cementite is the more probable. This is the formation of cementite is the more probable. So only 6.6% carbon has to diffuse to segregate to form the cementite that produce the 100% cementite. That produce the 100% cementite. What is the feature of cementites? So what is the cementite? So here cementite, it has the chemical formula Fe3C, and this is also called the iron carbon diagram. It has the fixed carbon percentage 6.6% carbon and 6.6% carbon, and it obtain the this carbon obtain the 100% cementite. 100% cementite. So it is the intermediate compounds. Intermediate compound, that is the metastable phase. So iron carbon diagram is not the true is not a the true equilibrium diagram, since means the no change of the phases with the time. However long time it may be, but graphite is the most stable form of the iron. Graphite is the most stable form of iron. Not iron. This is the most stable phase of the carbon. This cementite is the metastable. This is the metastable phase which decompose to the graphite if allowed a long time. So this cementite is the metastable phase. It is the metastable phase. It may be decomposed to graphites. Decomposed to graphites if it is allowed for long period of time. Long period of time. So graphitizations really occur. Graphitization really occur in the steel and may take the years to form. And Fe3C diagram even represent the metastable conditions can be assumed to represent the equilibrium diagram related to the behavior of the most steel. So a practically 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 FE 3C diagram is generally used generally used, but it gave the metastable conditions. It gives the metastable condition metastable conditions. But in the practical use, it is the sufficient to describe the all steel and the cast iron. So in the cast iron, the carbon content is the higher. So in the cast iron, you see the carbon content is higher, and high silicon content. This lead to the graphitization. Graphitizations. So Fe3C diagram is Fe3C Fe3C diagram is strictly valid for only at 1 atmospheric pressures. So this is the some features of the iron carbon diagrams. Now I will draw the iron carbon diagram, and we will understand how the iron carbon diagram look. Uh, so so uh, how iron carbon diagrams look, and how the phases are the changes, we will see. So for drawing the iron carbon diagram, I am not draw the clearly, but symbolic I have drawn. So here the carbon percentage, this is the very, and here the 100% iron, and here you see the 6.67% carbon, but it give the 100% cementite, yani Fe3C. Fe3C. So from here to here, so we can say the Fe3C diagram, and if we take the carbon percentage the more, so it is not clearly we can say the iron carbon diagram. We will see the iron graphite carbon, because beyond this limit we added the carbon that form in the graphites. So iron carbon diagram, so here uh, we see here the 100 degree centigrade, 200 degree centigrade, 300 degree centigrade. So we can say here is the 700 degree centigrade, and here this is the line of the 727 degree centigrade, 727 degree centigrade, and we can draw like this here, and uh, and here the 910 degree centigrade, 910 degree centigrade, and this is the carbon composition, say here 0.25%, and here 0.8% carbon, this is your U tactic point, and here the carbon percentage is the 77%, and this is the point of the, we can say, the eutectic temperature, degree centigrade here, and you see here the 1495 degrees centigrade, and this is the very small area, but now I'm making this here, and this is the 1539 degrees centigrade. It is the melting point of the iron, and from here to here you can draw this. This is from like that, and that is meet here. This is for the 1227 degrees centigrade is the melting point of the cementite. So this is the form, and this compositions from here, this is the 4.3% carbon. This is the eutectic compositions of the carbon, and this temperature is called the eutectic temperature. So this is the eutectic point, and temperature is called the eutectic temperature. Compositions is the eutectic compositions, and above this point here, all the liquid is present. So metal is started, the metal with the 4.3% carbon is start to solidify at the 1147 degrees centigrade, and below this compositions it is the increases along this line. This line is called the liquidius line, and here this is the austenite phase. We can say the gamma iron, that is the austenite phase, and here is the this is completely present the delta ferrite, alpha ferrite is it is simply we can say the ferrites, and here at this composition, this is called the eutectic point. This is the eutectoid. Here 100% pearlite is formed. Here the 100% pearlite is formed, and here alpha ferrite plus the gamma iron. Here is the delta ferrite. Here is the delta iron, and we can say the delta ferrite. Here the delta ferrites plus the liquid, and here are present the delta ferrites plus the austenite. Here the austenite plus the liquid. This point is called the peritectic point. Here, this contains the 0.09% carbon. Here the 0.53% carbon, and here 0.17% carbon. Or here the carbon percentage is the 0.77% carbon, and this is the 0.11% carbon. Here austenite plus cementites phase are formed. Here pearlite, yeah, we can say the ferrite plus cementites are formed. Up to the 2% carbon, this is the this cover the steel portion, and beyond this beyond from the 2% carbon to the 6.6% carbon is the all the cast iron. So that gave the graphical representations of these phases here with verses of the carbon with the compositions and the temperature. So on the y-axis at the temperature, and x-axis is the carbon. So this is the iron carbon diagram. This is very important. It is also very important for the heat treatment study, and it is also important for the interpretation the compositions and phases of the steel and cast iron. This gave the commercial guidance for the many complex alloy of the iron and carbon. So these phases, how much phases are the present in this diagram, and these phases describedly we will discuss in the another lecture. So now if you like this video, so please like the video and subscribe the channel, and thank you. If you have any doubt, you can write in the comment box.